right. Hello, everyone. Okay, my microphone is working, camera is working, everything is working. Except for me, so maybe I should get to work. Okay. Well, let me see. I somehow decided that now was a good time to copy some files to another computer. Not sure why, but yeah, here we are. It's gonna take about 5 minutes, apparently. But that doesn't matter. Today I want to work on my usual compiler project. Is this message going to show up every single time I open Firefox? It's going to be unable to restore my session. I have to confirm that I wanted to do that. Apparently. I wonder why software keeps getting shittier as companies keep investing more and more in AI. Puzzling. Puzzling. Okay. Before I do compiler stuff, though, I'm going to show a lot of changes in the operating system based on the pull request that used to be here is now merged to main, plus some other fixes that I've been doing, but mostly not my work, to be honest. So just, you know, just this little few changes over here. Okay. Let me keep this open here. So first off, I worked on a window manager, what was it, 2 weeks ago, kind of. And I haven't continued working on it because it has everything that I need for using the system, but yeah, it's not, I don't know, I'm not that familiar with window managers, and I don't really need any new features besides just opening windows and just like basic arrangement of windows. So I haven't given it too much attention. I guess I will once I start using the system a little bit more, instead of just opening it for a few minutes or seconds to test something. So it will become relevant, but it isn't right now. But it did have a bug where moving between windows used to be quite buggy. Now it works fine. There's just no animation, no visual feedback for it. If I switch there, that's better. Most of the changes though came from the terminal. Well, that pull request I merged has a lot of networking stuff, just fixes and IPv6 support, which I can't really test, to be completely honest. Because even though IPv6 exists, the average ISP has not been told about it. I have been told that IPv4 is like severely limited and whatnot, but apparently we're totally fine with it. We ran out of IP addresses, but it's fine. Anyway. Can't really test those changes, but some things in the terminal, like there's a blinking cursor now, which back when I made the terminal, I couldn't really add it. I don't remember exactly why. But I didn't have the right functionality in the system to do something like that. So I didn't add it, but now here it is. Made some basic fixes to oh wow, it's so much slower than it is on my laptop. Basics fixes to commands and to like output, the terminal reading the output of the command that it is running used to be kind of out of sync sometimes. There was a little bit of a race condition that made it so that you couldn't really read that, and so I fixed that. So now I believe it works 100% of the times. There were also some issues with um, the output itself, which were causing crashes, but that should be gone now, I hope. Yeah, we're doing compiler. I'm just showing some changes. Also, there's history in the terminal, which I have to say, every time I used the terminal, I tried instinctively to use the history and I couldn't. So now it works, and that's pretty cool. Um, Everything besides that, I believe, is just like small little internal fixes and improvements and whatnot. But yeah, just showing this because I wanted to show that, development of the system is continuing. Just since I'm focusing the live streams on the compiler now, which it'll all tie back together eventually, pretty soon, kind of. But until it does, I'm just doing improvements on the system, which were quite necessary. Okay. To the compiler now. I don't know why this command takes an hour to run. Thank you for this completely useless message. You can get git exclamation point git for the git link. Which, by the way, I should change that to be just the link to my GitHub and not the link to my project. So can I do that real quick? Stream Elements, will you allow me to do that? There it is, but if you want the link, you have to get it on YouTube, of course, but that's how you do it. All right, let me see. Which one is this? This is Twitch. So chat commands. Where are you? Oh my god, there's so many. Most of them are turned off. Here. Edit. Okay, there. I don't know about the project command. You can also run project, and that will tell you information about the project that I'm working on, but I have a feeling I'm not gonna keep updating it all the time. I'm just gonna make it a little bit more generic. My whole compiler is 3,000 lines. Okay. But it literally can only compile this. No, not even this. This. This is the only thing it is capable of compiling. Well, syntax like this. This is the only syntax it's capable of compiling. Okay. On YouTube, I'm gonna do the same changes real quick. Just remove that. Project and that. And there's no GitHub command on YouTube, so let me add it real quick. Semantic analysis would need a little bit of work. Yes. Parsing, yeah, you would need to update the rules, which technically will add a lot more lines of code to this file. But even if you ignore this file, yeah. And semantic analysis, the heavy lifting is being done by GCC, so that's why I'm fine with it. All right, just gonna test the commands that I just added. We're fixed. Okay. It's a little bit late on YouTube, but there it is. Did GitHub not work on either one of them? Or did I just do them too fast? Oh, there it is. There it is. Well, I don't think it worked on YouTube. Because you wrote Git at the exact time. But it's fine. Say everyone. Say everyone. Okay, well, either way. Is the link correct? That's what I gotta check. It is correct. And hey, my project has 200 stars now. It's in the 212. 5 for Doom, 2 for my game engine, 2 for my firmware server. That project is getting nuked, so don't bother. 2 for the cross-platform library, and 1 for Game of Life. Also, the operating system has been forked 24 times. And somebody forked Doom? My C compiler can also compile about that much, but most of its complexity comes from making sure that CU write is memory safe. Yeah, I want to do that eventually, but... Why did it say that I had a Doom... Oh, it's an inactive fork. That's why it didn't show. Why do you think Doom is in C++ GitHub? Jesus fucking Christ. Ugh. Vibe coded ass websites. You know, the weirdest thing about vibe coding is the fact that all of these companies are integrating vibe coded features into existing products. But you already had an existing product made by actual people who used to have a brain back in the day. Used to have a brain. Where did that go? I find it impossible that in so little time you managed to fuck up to this level. Where just nothing even works anymore. You used to be somewhat competent. Like, this project has more C++ than this one does. What happened to what GitHub used to be before you fucked it up? Like, obviously, any new features, I expect them to absolutely just not work because they're made by AI, probably in their entirety. But old features, I would expect there to be code that hasn't been touched in years. So how did you fuck up this badly? To the point that not only did you break any new releases since you started using AI and everything, but like also retroactively broke all the features that you haven't even touched. How do you do that? That's genuinely impressive. Alright, so yesterday I added classes to C, not through my compiler, through a macro. But that's dumb, so we're not gonna do that. I could have just undone changes on the entire file. Honestly, I would have kept it if I found a way to make it use any function here. And to put the entire function declaration, because it used to be just like bodies of functions. And that's kind of dumb. All right. What more changes are there? I just need to save. Okay, because it showed here that there was still changes. Okay, so compiler, where you at right now is that I really need to add executing to my build system so that I can just execute if compilation is successful. Because right now, really the best way to do it is to remove the executable, compile, and then run the executable. And if compilation fails, then it won't run. That should be handled by the build system, really. Okay, yeah, this is where we're at right now. We're able to generate technically all the useful information, but it's not really quite there yet. And yesterday, I was a little bit too tired to fix the logic of what's going on right now. So I would say we're 90% there of the way of generating C code the proper way, right? And then after that, we should be able to maybe start experimenting a little bit with the system. I'm thinking I definitely need to add functions because most code tends to be written inside of functions and not really as a script. Right now, if you look at my programming language, it's just a script. It just starts execution here and ends execution here. It doesn't really have functions. You have function calls, but there's no function declarations. I probably want to add those. I'm not trying to do like Python, where it's like, what's the syntax for a main function in Python? It's kind of crazy. Yeah, this. If name underscore underscore name underscore underscore equals to underscore underscore main underscore underscore, then execute your main function. I don't want to do that. So most likely I'm going to want function declarations. And then after that, we can start experimenting a little bit with the syntax of the language. Either that or compiling more and more C. Not sure which one I'm going to go for. GitHub Linguist has been giving false positives since it was created. When we're submitting a GitHub Linguist PR, so it supports our language, GitHub Linguist would detect our language to be something it isn't. Really? I mean, that makes sense, but like, bro, literally every file in here is either a .h or .c. Those are C extensions. What makes you think it has 95% C++ and 3.9% C? And what makes you think, what do you detect as that 3.9%? I know it obviously ignores the extension because if it didn't, it would just work. That's the funny part about it. You could have a pretty reliable system for detecting what language is in a repository based on the extension alone. That will get you 99% of the way there. That easy. But microslop. God, I'm so happy people invented that term. Microslop is perfect. Grammar system. Yeah, it feels like it. It's just like over-engineered. And it's over-engineered by people who have famously always been really bad at engineering. So like, well, I don't know about famously, but famously to me, I've always known Microsoft has never been good at anything, pretty much, except for contracts. They're good at contracts. And having their founder fly in a certain guy's plane and then be divorced by his wife over it. But besides that, they're not particularly good at literally anything. Safe sleep, that was a whole thing. It's not safe, it doesn't sleep. And it would cause... Did it actually cause like a monetary problem for people? I think it did, right? It probably did. Because essentially, the way that this is how they implemented sleep pretty much. It was done in a bash script, I believe, but this is how they implemented sleep. Say that we have like a timer, right? Yeah, they would make you pay. Yeah, that makes sense. Essentially, obviously, this would not work the way that I'm writing it. I just don't want to bother writing it properly. Again, just a very basic representation of how they did it. The problem with this is if there happens to be a little bit of delay and you miss the exact millisecond, the function doesn't run at the exact millisecond that it's supposed to finish sleeping, then it just runs forever. Does anyone know of any Microsoft products that were well engineered? That's probably an easier way of putting this. There are 10 types of people, those who understand hexadecimal and F everyone else. SafeSleep.sh rarely hangs indefinitely. Opened 7th of April 2025. So this has been known since the 7th of April, but I remember people were talking about this like late last year. So if this okay, what I did in milliseconds was wrong. It should be in seconds, but still. If the process is not scheduled for the 1 second interval in which the loop would return, then it simply spins forever. Here it is. While count sleep is not equal to 5000, then do echo sleep dev null and then count. So again, unless you run it exactly at the 5000 where count is exactly equal to 5000, which again is not going to be true at any second except for one specific second. So if by any chance there's a delay and that delay causes your function to not run at that specific second, it will run forever. Don't mean to hit the microphone. This, pretty much. While seconds is not equal to 1. They could have just used the sleep command. You know what? I implemented sleep, and it's kind of a pain in the ass. I mean, shit, between, like, the slight annoyance that is implementing sleep and, that shit, I would rather do that. But essentially, implementing sleep is kind of annoying because on Windows and Redacted OS, which they obviously were considering when they built the entire thing, it uses milliseconds, whereas on Linux and Mac, it uses seconds. So POSIX systems, their sleep uses seconds, which is kind of stupid. Because a lot of times you want to sleep to, wait, is it seconds or nanoseconds? No, it's seconds. Sleep, the sleep function in libc for POSIX systems uses seconds. They have another one that uses nanoseconds. Whereas on Windows and Redacted OS, they use milliseconds. And when I built my system, it made sense to use milliseconds because a lot of the times I have to sleep for a certain amount of milliseconds. A lot of drivers, for example, expect you to sleep for a certain amount of seconds before a response is given to you. That tends to be more of a timeout type of thing. Scheduling processes usually should be done in milliseconds. The CPU's timer is in milliseconds. Why wouldn't you just give me milliseconds? But anyway. So POSIX systems have either seconds or nanoseconds. Windows has milliseconds. So that is a little bit annoying, but like, took me what, 5 minutes to come up with a solution for it. Really, the most annoying part is that when you're sleeping, I actually put some sleep code in my compiler so that I could see step by step what it's doing. I deleted it, I think. Now, it should still be there, but commented out. I created an msleep function to make it explicit that it's millisecond sleep. And that's the one that's implemented. that way it works the same in all systems. It translates that to nanoseconds for POSIX systems, and it just passes it as milliseconds for my system and for Windows. Like, that's really about the extent of the annoyance. But the way that they implemented it is just so stupid. And God, who knew? They just happened to make money off of it. What a coinky dink. They're like, oh no, our script is making us extra money. Oh, we gotta fix that. I'm creating the Jira ticket as we speak. Your call is very important to us. BSD and Linux are the only operating systems where your compiler isn't forced to use cstdlib to do syscalls and stuff. Hella annoying when you want zero dependencies. Why is that annoying? You're not forced to use the cstdlib. But you can still use it if you want to, or you can use something else if you don't, right? I do have dependencies for cross-platform. Technically, my system has no dependencies besides a couple built-ins inside of GCC, which I could easily replace. A built-in for endianness swapping and for VA arguments, Veridic arguments. That's about it. Okay. Let me get to what I actually want to do today, which is, like I said before, my compiler is almost able to generate proper C code, but number one, I haven't implemented generating arguments for a function, and number two, it kind of fails sometimes. These here are the arguments for this function, so they shouldn't be getting printed out here. And so that and conditionals are struggling a little bit. And yesterday I was a little bit too tired to like check the logic of what I'm doing. So today we're going to do that. Essentially, the IR generator just iterates through the code looking for these tags, which indicate what a specific section of code is trying to do. Oh, Windows update that's tagged as security can technically change syscall codes. The backwards compatibility system can do that? No. Microslop. Anywho. Yeah, it just looks through your code looking for these tags that indicate what type of code is being generated by each section. So this word here could change the syntax of what an assignment look like, can change, but it's always an assignment based on this tag. This is the variable that is being assigned to, and this is the expression that's being assigned to that variable. With that, the compiler understands the code. And by understanding the code, it is able to generate an intermediate representation, which in a normal compiler, usually you can do optimization off of it, you can do static analysis off of it, you can even do static analysis off of the AST for that matter, pretty sure. But yeah, you can do a bunch of other things, and you can generate assembly and an executable off of it. But my compiler's version 1's goal is to generate C code, not an executable. And C is actually a great language. It has a lot of issues. The type system is not incredible. Array indexing is bullshit. Let me just be clear. Every time. This is my explanation for what my issue is with array indexing. Well, first off, this is valid, even though I created an array with 0 indexes. So what would that even do, for that matter? Probably undefined, or whatever the fuck that... Well, it literally means we don't know. Hey, curse devil. It literally means we don't know. So most likely this would be undefined. And that alone would be undefined. But also I can still index into the array. Even though index 0 doesn't exist because it has 0 items, I can still index into the array. But it gets even worse because I can also index like this. Because both of these two codes generate the same thing. Whoops. They generate code that looks like this, which is essentially write 1 into the register at this address here. So whether you do a plus 0 or 0 plus a, that's the same thing. So this is actually valid syntax in C, which is so stupid. Anyway, in case you were wondering what my issue with C arrays is, yeah, you can get static analysis on the AST, but it's not particularly useful. Yeah. You can basic stuff. But yeah, not super useful. So it has these issues, but it has a great advantage. It has very little, very little hidden complexity. And honestly, the hidden complexity in C is, let's not call it a skill issue or a knowledge skill issue. It's just a couple of rules that you can learn. Like the one that I just said, that this is the same as doing this. That's a very simple rule. Once you understand this, you understand that you can just do this. For that matter, is it valid code to do Seka? No, that's not valid. Okay. So one of them has to be an array type. One of them has to be an array type, but they don't necessarily have to be. But once you understand these very basic rules, because C is not machine language, so there is some level of translation, and it is somewhat higher level than machine language or assembly, or raw binary, which is just assembly but without words, essentially. You can very easily understand how C works, and once you understand that, you look at the code and you immediately understand how it works. For example, this function here actually has a lot of that hidden complexity that I mentioned. The first one is the array thing that I just mentioned. That. The second one is when you generate a local variable, like this one here and this one here, those local variables need to be somewhere in memory, and that somewhere in memory is within the stack for this function. So at the beginning of the stack, you're going to have an assembly instruction that looks like this in x86 assembly. Not x86, ARM assembly. Let's say that these two have like 64 bits of memory because I cannot be bothered. Wait, so that would be 8. 8 bytes. Which is to say, reserve 8 bytes into the stack for all the variables that are going to be within this function. Is that hidden complexity? Not really. It's not really hidden complexity. And at the end of the function, you take that space back. Hey, Ice It's not really hidden complexity. It's just, well, I guess it is. I guess it is, but like it's very, I don't know if I should call it hidden complexity or not. I guess I'm getting hung up on the semantics of it all. It really doesn't matter. The point is, it's something that you don't immediately see just by reading the code, but if you understand how low-level code works, you understand that this is being done, and it's not a particularly difficult thing to understand. Right? Another one is that housekeeping. Yeah, that's a little bit of housekeeping. The point is, just by reading the code, I don't know that this is happening. But it's very, very simple rules that C has. Another one is this one, for example, which here I'm initializing this object GSN with, I'm specifying the type of it, which is Stack Navigator. Sometimes this is not necessary. Like if I did this, I'm declaring a variable called GSN of type Step Navigator, and I'm assigning this to it. Oh, here I'm actually doing it properly. So I'm creating an AST node called node, and here I'm assigning this to it. What does this mean, as opposed to just doing this? Well, here, I'm just telling the compiler, there's a variable here. If you see me reference this variable, this is the one that I'm referring to, and also save some space in the stack. But that's it. What is in that space in the stack? Whatever was there before. Whereas here, I'm telling it, initialize it to 0. Which, if I'm not mistaken, this translates to this. It's kind of like doing that. It's just mem setting the space in the stack to 0 for that variable, which is useful. But again, it's extra code that you hide by doing this. Then the array thing that I mentioned, this is the extent of hidden complexity in C, really. Also a mem copy, I guess. When you do something like this, which is to say you have a pointer and you want to assign the value to it, what you're really doing is a memcpy into var from other var of the size of the var type. It's just shorthand for that, pretty much. That's the extent of hidden complexity in C, which is why it's a great language for generating code to it. Because that way, generating that code, I know exactly what the code is doing. And my compiler can add some, little bit of extra complexity to make my language more high level, but I understand what that complexity is and I get to control it. And it always generates the same predictable, easy to understand code. So that should make my language be have a less complexity. Comparing that, for example, to C++, godforsaken language C++, in which you will notice in my index map, which is really just a hash map, but that acts as an array. I really don't know why I did this class, but anyway, probably gonna get rid of it, but that doesn't matter. I guess it was necessary when I built it. The exponential complexity evolution of a C-derived language. It's so dumb that I have to have this. This happened on stream. I was creating an object of type index map by writing this. The reason I created it like this is because it has templates, right? So index map of type my type, which I misspelled. Oh well. New index map my TPE. That is how you declare a variable of type index map with template t my type in C++. When you do this, that allocates some memory for the index map, and then it initializes it using well, actually it uses a capacity operator. You can also initialize it with all zeros, but that's usually not expected. So you initialize it with an initial capacity. All right, so that's how you do it. And that runs this constructor over here. And this constructor is mallocing some memory, so you can then put the actual stuff that's going to be held in here in that memory. And then I had a destructor. The destructor is meant to clean up that object that was created here. Once I'm done using it, I can do delete IM, and it will call the destructor, which will clean up all that memory. Tiny issue. I was creating it, and immediately the memory that I was allocating in order to hold the objects that go inside the map was gone. It was faulting because that memory wasn't actually accessible anymore. Why? Because the destructor was being called immediately after construction. So it was creating an object, and then it was deleting that. And the reason for that is because this godforsaken language creates an object. When you tell it, hey, when you run this code and you're like, hey, create this object and put it in this variable. Right? This should be a simple thing to do. It creates an object. Then it copies that object. Then it destroys the original object. And then it gives you the copy. And that was causing issues because in deleting the original object, it was deallocating the memory that I allocated. So this one now was using deallocated memory. That is stupid. First of all, why did you do that in the first place? But that is exactly the kind of thing that, for example, compiling your code to C++ could cause issues like this. It's not necessarily a bad idea. For example, Unity does it. Pretty sure anyway. They have the IL2CPP compiler, which when you write Unity, you're writing C# code. That C# code gets translated, well, gets compiled into an intermediate language, and then that intermediate language gets compiled into C++ code. Then a native compiler is used to generate the platform-specific executable, which is going to be highly optimized. So in some cases, C++ can still be a valuable thing, because, for example, C++ is object-oriented, Unity is object-oriented, C#, which is what Unity uses for its scripting, is object-oriented, so it makes sense that you would compile to an object-oriented language, whereas C is not, despite the cursed thing that I did at the end of the stream yesterday. It is not actually object-oriented, so I want to add some very basic object-oriented kind of behavior, which is what I did yesterday with the macro, but like on a compiler level. But yeah, if I wanted to make an object-oriented programming language, like a fully object-oriented programming language, compiling to C could be done. Because for that matter, C++ kind of compiles to C. So it's just like layers. Well, it doesn't compile to C, but it is interoperable with C. But it does a bunch of extra stuff to allow that to happen. So that's kind of annoying. Since I don't have that much object-oriented behavior that I want to support, then I mostly just want to do interfaces, not even classes. Then I can easily compile to C, which could theoretically lead to some collisions in the sense that this here would be a class called jump code with this as its property, only property. It has a property called token, called jump of type token. And then it has a register elem, register subrule, and emit code functions, which gets compiled to this C code. Class name, function name, class name, function name. It's technically possible that you could manually write a C function with this exact name, but that's so unlikely that I'm not gonna bother too much with it. So I'm fine with translating an interface type to something like this. Okay. But like I said yesterday, we're almost there, but these should not be getting generated, and we haven't implemented arguments, and the conditionals are completely broken. The goto should go inside here, and this 100 should go in here, and it's also being compared to the x, which is not anywhere to be found. So, all right. The IR generator is the one that's generating all of this. It talks to the C backend because I want it to be kind of interchangeable, the code generation. I want it to compile to C, or I want it to be able to, for example, compile to a little debug representation, which just prints what's going on in the code. Or I want it to compile to an actual intermediate representation eventually, or I want it to interpret the code. Whatever it is, CodeGen can have whatever backend I want, which is currently just being defined by this macro. And here's the thing. Some code gets emitted, like actually written to text, some doesn't. So this assignment is token, 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 expression. Well, token, token, literal expression, which is itself a rule. That expression could also be emitted in code, but I skip it because it shouldn't be generated before this. It should be generated here. In some other cases, it should. Here, it shouldn't. But this should not be getting emitted, but it is. And this should not be getting emitted here. It should be getting emitted here. So the opposite is happening of what should happen. But I guess I have to go through the logic of this. We start out at block being told to emit whatever it generates. Block does not have a code generation rule. A block itself does not get code generated. It should, but it doesn't. So we kind of just, it doesn't do anything. It creates this gen object, but it's empty. So no code inside of it gets handled. And instead, it just recursively goes to the next object, which is a statement. A statement also doesn't generate any code because all it does is just decide the type of code that you're running. Like, is it a declaration, an assignment, a function call, a conditional, a jump, or a label? One of these. So it itself doesn't generate code. It just delegates to these rules to generate code, which are all of these. Then we get into the declaration. Well, no. The one that's not working, for example, is the function call. So it gets into the function call. The function call actually generates code. It generates code for a call, which is the compiler's internal representation of calling a routine, a function, a procedure, whatever you want to call it. Your language can call it whatever you want. The compiler calls it a call. It takes a function name, what am I calling, and it takes an argument or arguments. The problem being, this is being printed instead of being put in the function call. Now, I didn't generate any code generation rules for arguments, so I don't expect them to be in here, but I do expect them to not be here. So that's wrong. And this happens when you go inside it. Move, bro. These overlays can be so annoying. They're never there when you need them, and they're always there when you don't. They're being generated because of this. No gen pointer. So if the current rule doesn't emit, then this emits. That is correct, I think. The function does emit. Like, this emits code because a function call should actually be translated to C, whereas these other things that I mentioned before are not. So this should be true, and then this should be false. But hold on. I'm not sure if the condition like that is correct. Yeah, namespaces in C would be useful. I guess that's another thing that I want my language to have, but yeah, you've got a point. Most languages have it, and often sometimes it's very useful. Okay, that didn't change anything, so I thought that might have been the issue. But no. Where are we on the... Here it is. Current rule function call. Print, yes. Argument, prints, no. Expression, prints, yes. Oh. Okay, I see the problem. What's being printed is not the argument. The argument internally uses an expression type, and this is being printed. So, you don't pass down blindly. You should pass down your own value and that one. Okay, I think it's a bit hard to tell with all these prints. Yes, that is better. Okay, now they're not printing any of the useless information. Okay, like I said, arguments are not actually implemented yet, which is why there's this args not implemented thing. Makes sense. But the one that's still not working, although the code is a lot better now. If we compare it to the original code, the one that's not working is the conditionals, but everything besides the conditionals and the function arguments is there correctly. Int y, int x, y loop, x loop, draw without arguments. This is not fully finished, so that's a problem. I didn't notice that. There should be a +1 here. And everything here is empty. There should also be a +1 here. Everything here is empty. Printf is correct. So that's a little bit better. Now we don't have too much information, we have too little. But before we had both too much and too little. So we've solved one of the problems, and we still have the other one. All right, which I believe is going to be fixed after the ad break, because it's coming up right now. So I'll be back in 3 minutes. Okay, we are back now. That actually just ended. And I want to fix this bug as quickly as possible. Um, so uh okay. I see here this corresponds to the jump statement that should go inside the if statement, which is not being printed. Then block statement, assignment, expression, expression. This corresponds to this, but also not being printed. Okay, so this is correct. They should not be printed because printing would mean putting them before this, which is not right. Um, maybe? Yeah, okay. I was a little confused by the order here, but yes, it should be read sequentially, not backwards. It would print backwards, which is why we don't want that. We don't want it to print. We want it to print the assignment, which is the one that's generating this code. It's generating this expression, which is this one over here, but it's not generating this one. Which means the expression itself is failing to generate its code. And I'm going to put a period here. And if it says x equals x period, then it's using this rule when it should be using this one. And that is exactly what's happening. So the operand, I believe, is not being saved. No, wait, maybe it is. Let me see. Okay. So what I wanted to do, I didn't do it fully, is to also print the operand. Yeah. Transition table. The tokenizer. Might just. Oh, we'll see. Problem is I can't click that link, but if, you're in my Discord, I think. There is in the project suggestions channel, there's a compiler thread. You can add it there. That way I'll keep track of it, because in the chat I'm gonna lose it eventually. Okay. So yeah, the problem happening here with the expression is that this register subrule is not happening properly. So this expression should register this one as a subrule. Why are you crying? This one should have this one as a subrule. That seems to not be happening. And so this never gets assigned. And so this never runs. And so we end up with half of the code that we should have. But either way, what I did here was just a test. We don't really want to keep it that way because sometimes there are going to be expressions that don't have any kind of value. And I can see that there is no sub-expression, apparently. Why not? Is it because they don't have a sub-expression at all? because they don't have a sub expression at all. Well, that's dumb. So because that was missing, the IR generator ignored this part. It's just like, yeah, that's just syntactic. I don't need it to generate the code. Make rules. And it's segfaults. But that's a good sign. Right? That's always a good sign. Block statement, assign expression, sub expression here. So that did work. But it's segfaults. In printing, in eval rule. As always, GDB is just the most useless fucking piece of software ever made. Trust me, I'm being kind. All right. I don't get why there isn't a good debugger on Linux, besides it being GNU. Linux is great. I have my issues with it, but I can't lie, it's great software. Its usefulness cannot be denied as much as its ease of use can be put into question, which I do very often. GNU, on the other hand, god damn it, is it bad. That's what the G in GNU stands for. God damn no use. That's what GNU stands for. Someone come up with something better than that, please. I haven't come any closer to understanding what was failing, by the way. Because even though it tells me it was in eval rule, it didn't tell me where exactly. GNU find is 50 times faster on macOS than built-in find. Yeah, but that's Apple software is a little bit hit or miss. Mostly hit, but sometimes it's miss. Yeah, it would be great if you told me exactly what failed, but this function, I believe, has only one print that could be failing. I highly doubt it's this one. I highly doubt it's this one. Most likely it's this one, but you're just fucking useless, pretty much. What's weird about it? No. No. Which one of you is generating no? It's gotta be the assignment, right? So I don't believe it's even that. It's probably this. It's probably this. Right, that would make sense. If the error is here, why are you telling me that the error is in eval? God damn it, no use. Failed successfully. Oh, I think I didn't show off in the operating system earlier, actually. I just remembered. I'm gonna take a second to show it. Is that I failed something successfully. Maybe I already showed this. I don't remember. But anyway, one of the things that I added to the terminal is a test command, which runs tests that should be run from within a process. Right now, there's only one that checks that you can't read a file descriptor that doesn't belong to you. And so it says successfully failed to read from a non-owned file because I expect to fail there. So I have that. Another thing I also didn't show is a process monitor. Right now it just prints. There is also a kind of have to restart because it's a bit of a pain in the ass. There is a visual version of it. Just by passing any argument, it shows you a visual representation of the processes running on the system. It used to be there a long time ago, and I removed it. So, well, I didn't remove it. It's just like when I added actual windows to the system, it kind of disappeared because it was a full screen thing. So I had to temporarily just get rid of it. Now I'm adding it back. The thing about it is I want to make my terminal. First off, most terminals, as you know them, the Linux terminal and the macOS terminal, the POSIX terminals, are essentially, if you want to get pedantic about it, terminal emulators. Emulating this. Can you please work? Oh wait, I'm using the wrong key. Never mind. This godforsaken thing. This. Whatever software and hardware decisions were made for this machine drive one of the most important pieces of software in Linux and POSIX systems. Mac just relies a lot less on the terminal, but Linux relies quite a lot on the terminal. So the decisions that were made for this thing are still affecting us today if we use macOS or Linux. I still don't know what the people's issue with liquid glass is, to be honest. You just don't like it, I understand that. It's just that I've heard so many people say some really ridiculous shit about it. I feel more so, I've heard some influencer. Well, hold on, let me finish one thought at a time. Anyway, I don't want my operating system that started in the year 2025 to make decisions based off of something released in 1978. I feel like it's maybe time to move on. At least for me, I have the privilege of being able to do that. As such, I don't want my terminal to work exactly like a VT100 terminal, like a Linux terminal, like a Mac terminal. And one thing that I added to it is that you can run UI applications from it. Similar to kind of like how Plan 9 did it. The main way, at least as I can think of, to run applications on Plan 9 is still through the terminal, which is called RC, I believe. But yeah, there it is. The terminal runs a GUI application. Though it's buggy, I haven't finished fully bringing it back. But yeah. The thing about that is, of course, I need to consider how I want it to do that. Even though I don't want it to imitate the VT100 and all of its stupid complexity. Or let's not call it stupid. Let's call it 1970s complexity. I still needed to have some sort of rules. So I did add a very simple color system, and I wonder if it still works. Maybe I'll check later. To color text. Similar to what the VT100 does, but just using hexadecimal. So I added that. But even then, like technically your terminal application through some commands that look kind of like this. I don't remember the syntax. It's quite unintuitive. But yeah, some commands that look like that usually start with this character. You can control what's happening on the terminal. You can clear the screen. You can move the cursor automatically, kind of. You can color the text. And so I need to come up with a system to do that, just that feels a little bit more modern. And also to tell the terminal, hey, from now on, I'm going to be doing a GUI application. Because right now, if the terminal prints anything, like if there's one single print statement in the GUI version of the monitor, it will glitch and show both at the same time. So I'll need to consider that, and I want to think about it a little bit and maybe work on it on stream. Maybe Monday. I don't know yet. We'll see, but I need to consider what the system to communicate with the terminal should be like. Escape sequences literally starting with ASCII for escape key kind of tickles my brain. That's understandable, yeah. All right. So yeah, that. I'll have to think of a way of doing that. You know, controlling the terminal from the application running in the terminal, but without relying on the way that they did it way back in 1978 or whenever that was. A more modern way of doing it. Like I said, already you can control the text color of the terminal based off of hexadecimal values, which feels much more intuitive. But the syntax is still very similar to what they were doing because I wanted it to somewhat be similar. It's just that when I saw the actual syntax of what I would need to implement in order to make text colored in the terminal, I was just like, yeah, we're going with hexadecimal. I'm not doing this shit. Maybe in the future, and now I've decided not in the future either. But of course, I need to kind of establish a whole system for this type of communication, including the fact that the terminal could run GUI applications. Most likely, the terminal should just peace out after that. I don't know. That's how it works on Plan 9, if I'm not mistaken. You open a terminal, you open an app, and then you don't go back to the terminal. You close the app and you're done. But maybe I want to go back to the terminal. I haven't decided yet. Anyway, system. We're good now. Or why are we good now? Yo, Jester. If you're gonna be licking yourself, please leave. I can't have this every single stream. It's just the entire incessant noise of licking on my left ear, because usually it just comes in through here because he's right behind me. For hours and hours on end, 4 times a week is a little bit much. He only does it on stream too. Like when I'm not streaming, I don't hear it. Okay. Wait, no. The reason, okay. The reason that this didn't match this is because it was saved. Okay. So something is happening to the expression that's not emitting code properly. What I don't understand is calling this function when the object doesn't emit code should just do nothing. But apparently that's not what's happening. Compilers. Yesterday someone actually called that an intersection with C. So yeah, kind of. Because I want to expand it, but I also want to support some very basic C features. Okay, what I'm really weirded out by is the fact that this seems to run as sub-expression, calculating that. All right, so what is your problem with this? Can you not? it has a value. So the sub expression does exist. And also it should have an emit code. It does. But that function is not being called. Hold on. What's happening here most likely is that this isn't the object that I expected it to be. Yeah, it's the same object. Um, oh. This is probably the issue with that. This eval rule creates a code gen. This code gen comes from begin rule, which comes from here. But all this does is just create a struct. Which is then passed in as a pointer. Why is it passed as a pointer? Yeah, register sub rule. This shouldn't be a pointer. That's the problem with it, most likely. No, that is still needed. Okay. Yeah, so it's passing that as a pointer when it shouldn't have been. Now that means that every single one of these should change. Okay, quite a code refactor I have to do here. But fine. This, 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 and that's it. Now this void expression becomes a code gen t expression. Now that becomes that. And you check if it has a pointer. Okay, now I have to fix all of these. So these were empty, so that's kind of easy. Nothing's happening in them. Here, these void pointers become code gen t types. And you don't need to do this anymore, this ugly thing. So I don't remember why I didn't do it like this the first time. But yeah. Code gen t expression. Where they code gen t, and we just get rid of this ugly thing. And finally, last one, initial value is a code gen t initial value goes in here, and emits like so. Boom. Okay. Great. All right. So what is missing right now is, okay, we have x equals x plus 1, y equals y plus 1. We have conditionals inside here, but this is not being generated. And then the arguments inside of functions are not being taken care of. They're not being paid attention to. That's okay. Ask code, call code, conditional code. Here it is. The scope seems to not be generating. Why is that not default? That doesn't change anything. Actually, it should have not worked still. That's weird. Anyway, conditional code should emit. Yeah. Pretty sure it says print condition and print scope. And after scope, we're going to see that it says no code to emit. Here it is. Condition is admitting this the expression, sub-expression, expression, scope, no code to emit, so nothing gets put in here. And that is a little bit of an issue. Because this rule is not told to emit any code. And I would rather keep it that way, to be completely honest, because it is just a syntactic rule to chain multiple things together. Same as this one, to just allow multiple things of different kinds to be chained together here. So why was my hand shaking so much there? What the hell? I would rather these two don't generate any code whatsoever, but they should pass down to tell these to generate code. I would rather do it without them having to emit code, but that might not be necessary. That might not be possible, I mean. Oh well. What can I do? What can I do? What can I do? Is the problem, what's happening here is that the block is just like, yeah, I don't know how to generate code. I don't do that. So skip me. And so everything inside of here gets not generated. But I don't think there's anything I can do about that. I think these should be generated. So that means adding a new function type, samstat, and recompiling the rules. Everything works fine. But of course, we're going to need to create two more of these. One for the block, one for the statement. And all right, so how do they work? The block, the so-called block, just generates the code for the statement. And if it has another one after itself, it generates it. So it generates a statement, and if it has something chained, it generates that as a well. All right, so you don't register any elements. You don't do that. You register subrules. And that's based on the type being some stat, then code stat equals to child. And the other one, some scope is code chain equals to child. All right. And you should then, based on if this has a value, or if it doesn't, emit code for your statement, or emit code for your statement, semicolon, chain. There. And then for the statement, kind of the same thing happens. It's a lot simpler though, because a statement is just one operation, one line of code. And whatever that is, it just gets printed. Okay. So the seed code generator for the block returns scope, no, BLK code init with a break. And the arguments, like I said, I haven't implemented those. And case rule, wait, no, not rule block. Sem scope. Here I have to use sem, not rule. Rule is for parsing. Sem is for the compiler's understanding of the code. I'm also gonna get rid of all those rule functions. Why is this here twice? I didn't know you could declare a function twice in the same. I guess it makes sense, but wait, why do I have returns after these? I mean breaks after these returns. Probably gonna emit a bunch of times now, because we don't emit code in here anymore. Okay. We now eval rules, and finally, what buffer were we printing here? I would love to know that. What is this buff? Oh, it's just empty. Oh, no, wait. Oh, it's for the output. Okay, yeah. Never mind. I should get rid of it, but I'm not gonna get rid of it right now. Emit code CG. And it's segfaults. Can GDB tell me why it's segfaults? The GDC cannot. I can tell you that much. It doesn't know where it's happening. What a useless fucking program. Somewhere in emit code, inside of BLK emit code, you can guess where. Such a useless program, and then it asks you, are you sure you want to quit? They're absolutely useless, huh? And people ask me why I don't use GDB often. I just use printf. This would be why. Emitting code for the statement is not working. So I guess it's still segfaults. And it never gets to this stat thing. And again, it's not like GDB even told me where it's segfaults, so... This is running natively, by the way. It's not even running like on my operating system on QEMU or anything like that. It's native. So I guess this doesn't exist. Yeah. Weird. Oh. It's not registering any subrules. And most likely I can get rid of this should print thing. But I need it to work first. So. Ah, wait. Yeah, that's why. That is why. Okay. Now that has a value and it says a stat error, and did I hardcode that to always be the result or what? If there's no statement. Yeah, because likewise the same thing I just did, I need to do here. Alright, there we go. It emits the first one, but it doesn't emit any of the other ones because... I disabled that code here. Do I want to say boom? Wait. A boom. We're not done yet though. But yeah, need a little bit fine tuning on where I put my semicolons there, but we're good. Yep. Also here, not necessary. Yep. Yep. There's a missing statement. There's a printf at the end of the code that's not actually there, but it's generating code. Okay, so first off, the semicolon doesn't go here. The semicolon goes after each specific that's also probably not right. I guess it depends on the context in which it exists. So in a way, it kind of didn't fall out of a coconut tree, but yep. Function call, I didn't do. Yep. I just gotta do function call. Okay. Cool. But there is a missing expression. The last line of code is not being generated. And also, maybe you should have this. Yeah. That's better. That's better. Okay, but why is the last line of code not being generated? This kind of recursive thing gets a little bit hard to follow. I'm not sure where I should even put the print for it to check if it is failing or not. Well, there's only 2 function calls, so I can put it there. It only says generating function call once. So that's missing. But that should be printed a bunch of times. Registering the function call. Okay, there's too much happening here. Can't understand what I'm reading. Registering subrule of type. Where's that coming from? Yeah, get out of here. Oh. Type 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 9, 9, 9, 9, 9, 9, and a bunch more. Yeah, but it's still not useful. Okay. It detects two expressions, so both of them are being generated, but one of them is not being emitted. And it makes you wonder why. Registering statement 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Oh. Okay, because I used the exact same value for all of them, so it's not super clear what's going on. Conditional cond. Ish, what did I do? Jump JMP label label. Okay. 117713. So that's a declaration label label. Declaration label label function call 13. Then 4 assignment, 8 conditional, 12 probably the go-to inside the conditional, 4 8 12 assignment conditional thing inside that, 13 function call. But what's wrong with it? Well, I'm going to keep track of the type, not the typer, the type. So I can then print it here. It starts at 12, then 8, then 4, then 12, then 8, then 4, then 13, 7, 7, 1, 1. So it's doing them in inverse order, which makes sense because it's right to left in the generation. That's fine. But the first one is being skipped entirely. Hold on. Let's print it a little clearer. No. This is the condition to print if it's final or not. So this is where it recursively goes in until it reaches the final one. Why? It registers a statement type 1, type 7, 7, 13, 4, 8, 12, 4, 8, 12, 13. It does handle it. The 13 is the function call. It is being registered. It's so hard to understand what's happening here. All I know is it starts generating code from the second to last line of code, not the last one. It has multiple leaf nodes too, which makes no sense. If it's a statement followed by a block or a statement by itself, how can there possibly be leaf nodes after the statement? All of which have the exact same value, mind you. Hold on, I'm so confused. If only there was a program that could, you know, help me step through the code and see what's happening. That actually worked, that is. Okay, first off, the should print. I did get rid of it entirely, so we can get rid of it entirely. Since that is not necessary. Okay, the 272 is appearing 3 times for whatever reason. And I'm not seeing it a single time here. Okay, so first off, it handles statement 1, which is a declaration at the very, very beginning. When it finishes, it creates a substatement for it inside the block that it exists in. With 280, then 928, 576, 384, 192, 664, 782, 232. None of them match 272. Still, this value is completely wrong here. Statement 13, the function that is not being printed, is being registered in substatement 488634496. Oh wait, hold on. Am I omitting the same thing? Sorry, not omitting. Am I printing the same thing here? No, I'm not. Okay, that's probably why they didn't match. 832. It ends here. Why not here? You're registering a substatement of 723. Why can't you wait? IR generator takes the CG from here. Return gen. So confused. 440. This just keeps getting more and more confusing. Jesus Christ, I don't understand even what's happening anymore. There is one line of code that's not being generated, and I don't understand why. We start printing at 7770128. That is the rule being generated. Okay, yeah, I put that in, but I didn't put... This one here, 880, is not being stored by this one, 976. Why does it say we start... ChatGPT doesn't even fucking begin to understand what I'm doing. Or anything at all, actually. I'm a little surprised that this and this are different. Wait, but maybe this and this are the same. Yeah, that makes sense. Okay, there's an ad starting. Because it's been an hour, apparently. I'm gonna keep debugging this. Right, we start at 960. We start at 960. 960 goes to 312. 312 goes to this. We end up at 336, which is here. Why is 336 not going to the next one when it has a next one? Ask Croc. Oh god, I don't even want to know what that guy has to say about this. guy. Okay. I'm starting to understand. We start at 960, goes to 312, 312 to 664, 64 to 86, 648 to 336. 336 is claiming to be registering 432. Wait, this number and this number, this number and this number should match. There's also the fact that I'm printing all of these pointers as integers for whatever reason. I just started doing it because I wasn't planning on printing them as integers, but now I'm just doing it for consistency. But hopefully once this is fixed, I'll be done, and I don't care what format I'm using to actually print these. That doesn't actually matter. Either way. Alright, this is actually weird. Hold on. Registering substatement 664. Shouldn't this number match this number? Or this number match this number? One of these two should match. No, no, really, no, really, no, really. They shouldn't match at all because this is the wrong point. No, they should match. These numbers should match. Because these numbers match 760. Okay, starting to see something weird. When I save a value, registering substatement, I'm saving it as a child pointer of a certain value. When I read it, oh, I'm not printing it. Ugh, never mind. Uh, 48 is printing 312. 48 is printing 312. Hey, Arctic. $424. No, 32 is printing 936. No, we don't even get those, do we? I'm confused as hell mostly. How are you doing? My code generator is working, but it doesn't generate the last line of code. Now I have to read these godforsaken logs to understand what's happening. I still don't. Even after I'm starting to understand them. I really don't get it. 584. Okay, now what I should have done is this. What I should have done is this. Okay. Subscope. Okay, I'm getting tired of printing these as integers. They're so difficult to understand. At least here I can print them as pointers. I'm not done. Here too. AF can... Okay. Come on. Okay, so substatement 890. Oh, 8F0 gets saved to 890. Did you roll back the print code chain by accident? I don't think so. Okay, we start at 890. We'll never know because it says start at. This is why I didn't want to switch back to using pointers. It's proper, but if you forget one, then you don't understand what you're looking at anymore. Okay, 890 is the starting point. 890 is the starting point. What I'm a little bit surprised by is that there is no 890 here. Oh no, here it is, 890. Points to 9F0. Nine F0 points to B50, B50 to C10, C10 to CD. Okay. This one points to 0. Mostly for fun, honestly. A little bit of prototyping, mostly for fun. This is so fun, can't you tell? Oh god, okay, these prints are starting to not make sense anymore. What I'm a little bit surprised is that this... No, this does match this. Okay, so registering statement 13. Substatement 13 is matched by this 821. But then this matches this, right? 98, 26, 890, 98, 26, 890, yes. And then the 9F matches this one, the B5, the C10, the CD, EE0, and then it changes. Oh wait, this is probably the block inside the if statement, so this one doesn't count, 1250. But the next one after that is 1090, which is here, 1310, which is here, 1780, which gets skipped, 15C0, which is here, this one is not being registered. Okay, now I see the problem. Now I see the problem, surprisingly. This code is... It's like in the thing in the Matrix where they're just looking at symbols and the guy's like, yeah, you eventually get used to them, you understand them. That's how I feel like right now. Okay, so it seems like statement 12, which is... Oh? Wait. I just learned you can do that with the scroll wheel. I didn't know that. I accidentally put the scroll wheel here instead of here. Statement 12, which is probably this. No, hold on. Hold on. That might actually be a key. What is statement 12? The condition, okay. Statement 12, which is the if statement, is not correctly saving the statement that comes after it, which is the printf. Even though the printf is saving the value of its thing, it is then just not being generated in any way. But that's not it. That's not what's happening here. Registering statement 12. Then it goes to... Wait, is that anywhere else? No. Hi, MX. Hmm. 12. Here it is. Evaluates its own statement. Then does rule 14, which is arguments. 13, which is function call. 2, which is statement. And 9, which is scope. Nine, 2, 13, 14. This gets registered. The statement gets registered. This does not. Because is there anyone who's actually able to follow this along? Because if so, you're doing better than me, by the way. Just want to make that clear. Okay. There's a lot more happening now, but It's this one, right? 912 2. Well, I think I understand. It looks like the final block statement is generating a 0 as its final pointer. So the eval rule of this one is generating a 0, which can only happen here or here, right? But I'm not seeing... I see. I see. I see. Okay. Understood. So I had the cute little idea of creating a ternary operator turn, which in this switch rule function that's returning it has 3 different values. True, meaning I was able to move to the next rule. False, meaning there was an error. And -1, meaning I'm done. There's no more rules. I've finished my job. And I confused the two. When you finished your job, it was returning an empty rule instead of returning the correct value. Boom. God damn, that was difficult. That was fucking annoying. But it's working. 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 Okay. Almost done with the code generation. We might be able to move on to some more syntax and maybe some experimental syntax. I guess we shall see. I just want to get rid of all of these prints. So that we're left with the code. The last thing I have to do is implement arguments to be put into the functions. Right. So before that, there is one more print to get rid of, which is this one. And you know, in both of these cases, it should be correct to do this. Okay. All right. So to do that, arguments, it's going to be simple. I just have to do code gen arg code init. I have to create that function. I then have to create a new class for arguments called arg code. That's going to be the one that we're handling here. And what is it going to have? Well, it's based off of expression, comma, argument. So it's going to work kind of similarly to how this works. You generate an expression and a chaining operator. Similar to how blocks work, actually, except they're separated by commas, not by semicolons. Oak. So, you don't have any registered elements. You switch on the type of the function being semargs or semexp, and you store them in different places based on that value. and then you emit them. If you have a chain, then you calculate the chain. You want to emit code for your argument. That is chain expression. That's it. Followed by the code for your chain. If not, you just want to generate the code for your expression. Okay. That is how arguments work. Oh. Yeah. But then you need to actually implement them. Emit the code for the code arguments. And it seg faults, and God forbid this thing is useful, but we're gonna try it anyway. Found a token instead of rule. Did it always say that? Because I feel like I didn't see that in the print before. No, it's there, it's there. Found a token instead of rule. Hold up. That print is not coming from here. Oh, it's coming from here. Okay. So you're saying you found token to slice node T instead of rule node rule. And now it doesn't even print anymore. Jesus fucking Christ. I would love to know how exactly this is seg faulting when the exact same code is being run on the semantic analysis side and it's working fine. So let me guess, this is some garbage value? What do you know? What do you know? Where are these being generated? Some garbage value being put in here. If I'm not mistaken, in the emit rule, token is being initialized to 0. Here it's being given a perfectly valid value, so who the is doing that? And why did it only start now? And what is the meaning of life anyway? I do know one thing. I haven't seen this. Too many arguments on line 18 of IRGen. This is not being used anyway, so it's fine. Also, it's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Is 5 bigger than 5 according to This looks like 5 arguments to me. Oh, but because it doesn't recognize the V, it considers it to be too many arguments, I think. Okay. Well, you do you. Either way, I don't understand what's happening. Why all of a sudden, out of nowhere, kind of, this became a problem? When here, it also happens now. Oh, this is not being returned. That's why. Probably. Yeah. What do you know? So what was causing a garbage value? Probably yeah, it was probably desynchronizing my system. There we go. We have generated code. Valid C code that looks exactly like the input. You love to see it. All right. I love that the output of this whole process, of this entire debugging session that's lasted 2 hours and a half, has been getting the same thing that I was getting before. You love to see it. You love to see it. It's literally the same code, just the indentation is different. But it's literally the same code. There. That's, I believe, a 1-to-1 now. This is my generated code. This is my output code. The only difference is in the spacing of the arguments here. Whereas mine puts in spaces, here I didn't put spaces. Well, there we have it. I want to eventually have, what do you call it? A formatter that handles whenever there's a new line, put in the indenting as well. And when you increase scopes in certain cases, keep track of that. When you're emitting the code, it can be useful to auto-format the code like this. But frankly, don't care too much for that right now. Okay, I'm going to very quickly just keep track of the thing that I'm doing. I ain't reading all that. I think it's fine. Yeah. I'm keeping... I'm just getting rid of whether it prints or not, because that's no longer a thing in this. And I'm getting rid of that. And I'm getting rid of that. And I'm getting rid of that. And I'm hoping that that's enough. All right. there we have it. C generator, well, C compiler generates C code in the most useless waste of compute power since anything that Microsoft has done ever. And safe sleep in GitHub too. So I can now start messing with the syntax of my compiler and all that stuff. I can either start creating my language or parsing more of C. Either way, one thing that's very much missing is parsing, function declarations. Function declarations are not being done, and that is a big issue. Because that is what's preventing the currently kind of mostly somewhat Turing complete code from, well, Turing complete in the sense that it calls functions for anything that it doesn't know how to do. But still, it cannot declare functions, so that's a little bit of an issue. Or is it? I don't know. I can either implement that, or I can implement features of the language, but I believe I need to implement function calls. Function declarations. I have function calls, I don't have function declarations. Okay. What does a function declaration look like? First off, it has this funcdec, which for the time being needs to be hard-coded as an enum here. That won't always be the case. Right now it is the case. That won't always be the case. Probably gonna get rid of this off stream. It's just a little bit of a refactor. These are just integers, so you can get rid of them. And if you want to know them, there's this rule name function. It can all just be auto-generated. But either way, what does a function declaration look like? Well, we have a type. Followed by a block. And here's where it gets a little interesting. These arguments are technically their own rule. I'm gonna call it param. First off, in their syntax, they're different in the sense that they're similar to declarations, identifier type, identifier name, but they don't have this part. There's technically functions that are like that. I mean, not functions, declarations that can be done like that. But they're very much not the same in this case. Right. So this should be valid. In order to make it valid, I need this type of statement. Which is identifier for the type, identifier for the name, then a comma, then an argdec, or just one. And a function call is an identifier for the type, an identifier for the name, a left parenthesis, an argument declaration, a right parenthesis, a left brace, a block, a right brace. Okay, so syntax-wise, that is it. I created this param, which I also need to register. This one's a little bit more difficult to get rid of. Okay, and the rule argdec. Forgot to register that one. That still failed because there's an error in the rules being generated. Here, right? Type a name in the sim check. I see. What determines if you do a sim check or a declaration? If it's dec. And who determines if it's a declaration? Whether it's a dec, a label. Well, there's some new ones. Another kind of declaration I just added is the argdec and the func. Is it that? Func and param. Param, not argdec. Okay. So the rules are getting parsed, but it finds a syntax error here. If I get rid of that, it works. Found syntax error on line 1, chapter 9. It's, let's see. A function declaration is not a valid statement. I forgot to do that part. I forgot that a function declaration should probably be a valid statement. Okay. That parsed, generated the code, but it said statement error, which I'm pretty sure just means I don't know how to generate this. Pretty much that's what it means. You gave me something here that I don't frigging understand. However, before I get to the code generation part of the function generation, this actually went better than I expected it to. That means the parser is more stable than I expected it to be completely honest. That's pretty cool. Either way, we're not registering the function as a symbol that exists, right? So that's kind of a problem. That's a little bit of an issue. I believe, anyway. Let me see. The conditional argument, here it is. Argument declaration is a parameter and function is func. Okay. Yeah, but semantic action declare. Who decides that? When we're doing a... Where is it? When we're doing a declaration, we have it marked as semdec. which indicates that we're doing a declaration. Wait, so it might actually be set up. I just need to well, I'll be damned. Yes, actually. All I needed to do the semantic analysis on it is just include it in these cases here. And it says symbol empty here because sem rule name, which is here, does not have a lot of the new types. So can we populate it with code actions? Thank you. Incredibly helpful, actually. If it's none, we empty it. If it's case also, we return nothing. If it's stat, we also return nothing, as a matter of fact. And if it's param, return parameter. So now it says symbol parameter type int name b, symbol parameter type int name args. Oh, I actually called it that. I didn't realize. Name a, symbol func type void name. Let's give it a better name. A test func. And then symbol declaration type int name y, symbol declaration type int name x, symbol label type none, label not bad, not a bad. And finally, we'll need a generator for these two. One for the params and one for the functs. If I want to emit that code anyway, which I probably do. Okay, so arguments and parameters are incredibly simple, so I can just copy the code from the arguments to create the parameters. What do they look like? They have actually a token type, a token name, and a chain for the next one. So you generate the type, you generate the name, then you generate the chain, or you do just the first two. This is param code emit code. And then this is type. No, these don't go here actually. Wait, oops. This is arg code and this is param code. Okay, now we're good. The only thing is that the code for this should look... No, wrong place. Here. Param code. If it's sem type Wait, is that right? How do I do it in a declaration? A declaration switches the type on some element types. It's pretty much the same code as this. So I can literally just copy this, get rid of this, and there we have it. It should now be able to handle parameters. It just needs to be added here. Case sem param, return param code init. And while I'm at it, sem func, return func code init, which I now need to create. Kind of similar to this. If it's given a type, it saves the type. If it's given a name, it saves the name. If it's given an argument, it saves it as the arguments. If it has arguments, it generates like so. If it doesn't have arguments, it generates like so. I forgot. It can have a block. Yeah, probably the function should have some code that it executes. That would be ideal. But I'm actually going to make it optional. Because eventually I might want to have extern functions. Just for correctness. Yeah, no, we're not there yet. I hate segfaults. Do we think GDB is going to help this time? I'm going with no. Surprisingly, yes. In param emit code, it doesn't tell me which one of these is the one that's failing though. But based on what I'm seeing, it's the one on the bottom. Is it missing the code type or code name? Okay, that was more helpful than I ever expected GDB to be. It's pretty much just the fact that these should be V arguments, not S arguments. That's still not it. Well, the same thing happens here. It's the same thing happening again. And you may not believe this, but I completely forgot what it was that caused there to only be a missing statement at the end. Now there's a missing argument. Only one is being printed, but without a comma. So that means that this isn't empty. It's just not being saved because probably it's samparam. Yeah, that was it. Okay, good. So once again, code is generated correctly. Perfect. Damn. What do you know? My code works. Genuinely a little bit terrified of that. Because, like, what do you mean it works? Are you sure about that? It's kind of weird. Damn. It works. All right. There was something that I needed to do and I forgot what it was. Completely and fully forgot what it was. By the way, I kind of have to start paying attention to symbol table scopes now a little bit more because I now have functions. But I'm again not really paying attention to semantic analysis this very second, so I'm okay with not doing it this very second. Okay, yes, I remember what I wanted to do. I wanted extern functions, right? Which is it's an interesting test of how flexible I can make this whole system. I added this, cool. Added this, cool. Added all of these. Yep. Mm-hmm. Mm-hmm. Yep. 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 So, sometimes you don't want to declare your function right away. You just want to say, hey, this function exists, it looks like this, but you don't want to actually implement it. It's implemented somewhere else. That's where you use extern void draw int again, because I'm not using scopes for symbol tables, I'm just gonna change the names of the variables a little bit just to avoid confusion. It's not gonna generate a problem or an error of any kind. Right? My function looks like this. Or even right, so there's that one. And then there's printf. Printf, however, takes veridic arguments. And that's a whole other can of worms that I'm not interested in opening right now. So I'm instead going to declare an extern void printf with a sharp pointer. Pointer is another whole can of worms. Never mind. Wait, do I even want to declare extern functions? Yeah, what the hell? Let's do it. Let's not. Let's not. I don't want to do this. I don't want to do it. Turns out I'm in charge here, so I can just choose not to do it. All right. Let's instead start messing around with the language a little bit. For example, I mentioned yesterday when I was kind of declaring what some of the syntax should look like, I was saying if the function returns a void, it shouldn't have an explicit void return. If it doesn't have any arguments, it shouldn't have any parentheses, right? So let's begin implementing that. So a function declaration can look like this whole thing, or it can look like this whole thing. Eventually, I would love to make both my parser and my rule generator a little bit smarter, and simply being able to say type is optional. But I can't be bothered this very second. So, also the rule generator is definitely not there yet to do that. It's all the complexity that I added to the like code generator, parser, semantic analyzer, it doesn't have. So yeah, it's not the best. Either way, I want a function declaration that is just function name, left parentheses, arguments, right parentheses, left brace, right brace. Cool. So I can just give you that rule, and you should be able to parse correctly. Did I even add a function that looks like that? No, I didn't. And yet, it works. The only issue is, number one, the function code generator does not know that there is no type. And number two, it has no type, technically. It doesn't know what a empty type is. And this is kind of where the symbol the symbol table comes in handy, which right now I couldn't be bothered. All I'm doing is just taking the exact same type that my input code takes in and generating that as C code. The problem is, what if I want, instead of int, U32, right? Like Rust does it, which is also so much simpler. It's probably one of the few things that Rust syntax does better than C syntax. U32 in...
My code does not work. NDDKY.
Sorry to hear that. U32 translates to uint32 underscore t in C code. So I can't just print out U32 as the type. Which is why the semantic analyzer needs to get a little bit better. It needs to understand, okay, you're telling me U32. In your language, that means unsigned integer 32 bits. And then save that. And then the code generator needs to be able to look into the table and be like, hey, tell me the type of the function that I'm generating right now. It returns a what? An unsigned 32-bit integer. Okay, I call that uint32 underscore t. So, long story short, I can write this, and the code generated looks like this. So that little bit of complexity is something that I currently don't have, that quite limits me. And my language is, well, my code generator is using the tokens directly. So it's taking and pasting, you know, which is not great. So the semantic analyzer needs to improve a little bit. For the time being, that means that the code generator for this shorthand doesn't know what to do with it. It's a little bit of a hack what I'm gonna do for it, but essentially, if there's no token for the type, you just default to void in the code generator, not in the semantic analyzer, but in the code generator. And if there's no arguments, then you default to void in the code generator. Eventually, maybe tomorrow, maybe next week, I will expand the semantic analyzer to be able to do this properly. So I'll put a to-do there. And the language is transpiled to C, so compiled in a very roundabout way. Okay, here. Wait, I'm gonna add a new function to my string slice class implementation thing that handles just taking a literal in order to power what I'm doing right now in a better way. String slice, it already has this make string slice function. But I want to have a static inline string slice from lit that just returns make strings slice from buff start at 0 strlen of buff. I don't even need to recompile the operating system and just use this function void. Wait, did I leave the U32 there? I shouldn't have been there. It didn't do it though, because I didn't replace the argument. There we go. Now, if you don't specify a function type, it defaults to void. Again, a hack, but we'll fix it better either tomorrow or next week. There's an ad coming up, so I'll be back in 3 minutes. Okay, add time is over, and my compiler works. I know, shocking. But I even created my first non-strictly C function type, which is no explicit return type in a function if you don't have one. And also, I want to do the same thing for arguments. Right now, if I try to compile this, it will be an error. On line 4, column 10 is not exactly right. It says that the error is here. A little weird. Again, the error messages are not the best. I'll have to improve them eventually. But, yeah, I want to be able to support that type of thing. This is where it gets quite annoying to have the rules the way that I did them. Because in order to support no return types, I have two different ways of parsing a function declaration. One without and one with a return type. If I want to support also no arguments, I have to support no return type and arguments, no return type and no arguments, return type, arguments, return type, no arguments. I have to support 4 of these different things. That's annoying as hell. It kind of, I guess, will encourage me to work on the rule parser that generates based on these things to support optionals, and also to get rid of the hard-coded function rule names and all that stuff. But we don't currently have that. So we have to make do with what we do have. What you gonna do about it? You gotta do what you gotta do. It is what it is. Would you look at that? It actually properly generated our void second func with no arguments, which prints A from this. Cool. Cool. I'm glad that we have this. Not only that, but of course, everything can be nested. So if we want to, we can just put the entirety of my code in there, and it isn't formatted the best way, but we can see that second func, no arguments, void return contains all of this code up to here, just like it actually should. And hell, we'll call him main, and bada bing, bada boom, we got this. For that matter, I am technically, I probably don't want to keep this. But maybe I want to keep this. We'll see. This is technically valid syntax as well. I can have the function inside of another function. And there you have it. There is a function being generated inside of main. And this is where we need to consider a little bit of what we're doing. A little bit. This is where things can kind of start to break down, because this is no longer valid C code. First off, the name main probably won't help with compilation, so we'll change that. Second, function definition is not allowed here. Third, draw doesn't exist. Oh well. I was about to support externs, but I decided not to. This is where the current code generation starts showing its limits, and we have to start thinking about the next steps after what we currently have. Because even if I end up not supporting functions inside of functions, I still have to support lambdas. Otherwise, why are you doing a language on top of C if you're not going to support fucking lambdas? Especially when you already kind of have lambdas in a bunch of places with macros. That would be stupid for me not to have a lambda. But in order for me to have a lambda and translate my code to C, that needs to be declared as a function outside. Right, so the way that I thought of fixing this problem is right now we're generating code on a tree-like structure, right? We're creating a abstract syntax, not tree, but an well, it's still a tree structure, but an abstract C tree without the PO. Which is to say we're just generating C code in terms of abstract structures, right? We have a block which contains a statement, which contains a function declaration, which contains a block, which contains a statement, which contains a block function declaration. That's what's happening here. And then we're taking that and we're going through it sequentially, and we're generating code, which is cool. But it isn't always the correct way of doing it. I believe what I probably want to do is generate code on kind of 3 layers, if you will. I haven't fully decided how to structure it. But a lot of the times your code has a prelude. That's not prologue. Prelude. Yeah, so what I was saying before about C functions, right? When you create a function, all of the local variables get allocated in the Slack, not in the Slack, in the stack. Also, I'm sorry to the corporate workers that I triggered on this Saturday, including myself, by saying Slack. Right, so let's ignore this for a second and consider I'm generating the code inside this function, right? And I'm generating this declaration. Well, what I need to do is in the current scopes prelude, or how do you pronounce that word? Hold on.
Prelude.
I don't pronounce it like that. Hold on.
Prelude.
Prelude. Thank you. In the current function's prelude, I just do what I said before. Right? So what for? As I'm generating this, I generate this above it, and then I generate this. Well, this would be generated as like, not really like that, but yeah. Essentially the equivalent of this. as I'm generating this, I generate this, but I also generate another one of these. And then at the bottom of the function, I'm generating the opposite. Same thing twice. So I'm kind of generating code in 3 different places at the same time. At the beginning of the current scope, in the current location that I'm at, and at the end of the current scope. So most likely, if I want to support something like nested functions or lambdas, I will have to do that. Because this function should be generated here. Right? You can put it in here in your code. The compiler can parse it there, semantically analyze it there. If you try to use it outside of here, once I have proper scopes, this shouldn't work because the test func exists here, not here. So this should fail for the compiler, but when it comes to actually generating the code, it should look like this. Again, that requires making the code generator that I just fixed and finished today more complex than it is. We also need to make the symbol analyzer a lot more complex than it is. In general, and I need to make the rule parser more complex than it is. Hopefully that one I will do during the week off stream, because it's a lot more tedious than this kind of work. But for the time being, it's nice to see. And also a little bit of code formatting would be nice, because this can be kind of hard to read. When I saw this, I was like, oh no, it failed. But no, it actually put this inside of the function. There's just no indentation, so it looks like this. So yeah, the code formatter should also be there. If we want to make C code, we want to make at least pretty C code. But hey, we can generate C code already. And we can have a little bit of the syntax like I wanted. So this kind of thing. Like I did here, for example. So that kind of thing is something that I want to have. But the more I add features to the compiler, the more it becomes obvious that both the semantic analyzer and the code generator will obviously need to increase in complexity quite a bit. For the time being, I'm hoping the parser doesn't, until it becomes time to make it more performant, that is. And to give it better error messages when you actually have an error. But we'll get to that point. There's a chance that I'll even like scrap the way that it works and just use a properly generated parser. But we'll see. Okay. So there's that, but those are things for the future. Right now I'm reaching the end of the stream and I'm considering, are there any more very basic syntax things that I can do in my language to start experimenting with it a little bit? For example, if statements without parentheses. We're getting quite experimental here. Again, I really want to add optionals to the rule generator, because then it's going to be so easy to just do this and this. And that fails because I didn't regenerate the rules, did I? And that succeeds. And it adds the parentheses back because now it doesn't just blindly generate code from the input, it actually understands the code that it is generating. And in the same way that we understand the code that we're generating, we can also do more things. We can analyze the code. Static analysis is a kind of very useful and very common thing to do in compilers, especially modern day compilers. Very common to do C, but with more type safety and memory safety, that kind of thing. So that is a lot easier to do with a binary representation of your code, which is what we have now that we are generating C code. We're eventually emitting this, but before we do that, internally, this looks like a tree structure of C code. So no matter what these rules look like, the internal representation looks the same. Let me see, what other things can I do? Well, I did this before, so I might as well add it. Don't know if I like it, but creating these types of function declarations. Yeah, no, that's incorrect. First off, it needs to start with var, otherwise what's the point? And error on line 6. I said var x colon int equals 0. Var name colon type equals expression. I can't say I see the problem here. Maybe the parser is breaking down a little bit. Never mind. There we have it. Except this failed a little bit. It seems like the function symbol dec type int name x. So the symbol table is correct about it, but when it's generating the code, it seems to detect them wrong. If it's type, you should save it as the type. Then output the type. But it's instead generating int equals 0, which is not exactly right. Makes me wonder why the name of the function became of the type became. Wait, it's this one first off. Type int name x. That is correct. So this is detecting it, but somehow this is not. I have to say I'm surprised. Can't say I see any big reasons why. Type name equals expression. var name colon type equals expression. Either way, this is not really a rule that I wanted to keep, so let's just get rid of it for now. It'll probably come back eventually. Let me see, what else did I want? There is linked objects like this and link function calls, which is gonna be an interesting one to do. But I do wonder. Oh, right. What section of this real code can it actually generate? It won't be able to generate this because it doesn't have nested function calls. So that'll have to change. So if you have a compiler, you have to specify a compiler. It won't be able to generate that, but really that was supposed to be shorthand for this, so I can just do this. Semicolons are currently not optional. Memset, I believe, is fine. This is fine. What isn't fine is the else. Any other things that are weird? I believe not. Let's try it. No. Line 14. Kind of unexpected to have seen an error on line 14. String format buff is a correct function call, right? With this buff, whatever that might be, because it's not actually here. A buffer size, a string argument, but this is a string argument and it works fine. And this. See, this is where the current parser kind of breaks down a little bit. We don't know what's causing this. Well, we know it's on line 57. It's like, oh, it's the output.data. Okay, it's that. But of course, all these variables don't actually exist. It's a little bit of an issue. And there's a million of them. I think it's easier if I just turn off semantic analyzer, because it's not even doing anything. So I'll just skip it. It worked, but it didn't print everything. What obfuscation techniques work here? What? Okay, print has that big issue right now, which is that it... I need to deprecate the printf syscall, just get rid of it. So if I want to just use the default one, I can. And I guess I can replace it with put s. Puts. Which comes from stdio. Are you adding stdio to this? No. Too many arguments. Oh, right. This doesn't take arguments. So you do it like that. Huh? What? You're using an stdio function. Why are you... Oh. Oh. My string generator is super limited right now. Ooh, that's a problem. Oh god. Okay. So what's happening here is the string generator itself is like, hey, there's too much going on. I don't I don't know how to read I don't know how to print this. So the string formatter itself, which is my own formatter, is limited to 256 characters. I tried lifting the limit once, it didn't work, and I didn't try again. I tried for like 5 minutes. I probably should have tried a little bit harder than that. I was just like, yeah, I don't have time for this right now, and I haven't fixed it since. Either way, technically, the code generator right now works with string formats. Not exactly correct. The way that it should work is it should actually emit code. Like, okay, put this in a buffer somewhere. And in so doing, it will also, first off, it will lift this limitation right away. And second, it will allow me to do that thing that I said before, where you can have like a prelude, body, and footer. But since I currently don't have that, well, I guess we're a little bit limited for the time being. So let's just put it to do and end the stream here. Okay. Technically, it was able to compile this. A big thing it doesn't currently handle is expressions that have like chained properties and whatnot. Because, you know, you can do... This is what I believe I was doing here, which didn't work before. As well as this, both of which should work. I currently don't have them, so we're going to be expanding the language a little bit. And actually, I think that is a good way of expanding the language. To do so by taking these bits of code that I wrote and expanding the language until they are parsed properly. But that is a thing for tomorrow, not a thing for today. I'm going to be ending the stream now. I'm just going to very quickly end this. And I don't want this code, but I do want this. The syntax is gone, actually. So, there. I also probably need to see what was going on with that. Generating an int instead of an int x. But no big deal right now. Okay. So that's going to be it for today. Tomorrow, I am probably going to fix the code generator because that is probably going to be my biggest limitation going forward. That and the parser being very cryptic about what errors it has, but that one can wait a little bit. And not having optionals and rules, but I'm planning on working on the rule generator in between streams, so like during the week, since that is a lot of what I'm doing now, but more specialized towards the rule generator and a little bit more tedious to do. So with the code generation techniques that I created today and the code generation techniques that I'm going to be expanding tomorrow, I will be able to create a much better code generator even for the rule generator. So that's going to be quite useful. Okay, but tomorrow, yeah, I'm going to be doing proper code generation instead of just basic string formatting. Maybe I will actually use a code form or create a code formatter because that's a useful thing to have. But we will be doing that tomorrow. Okay. So thank you so much everybody for joining. I'm going to be linking Discord or not because OBS decided to glitch on me. I'm going to be linking my Discord And the next stream is tomorrow at the same time as today, 3 p.m. Central European time and 2 p.m. UK time. We'll continue working on this compiler. And actually, based on how far I get the compiler tomorrow, on Monday, I might port the compiler to my operating system, start doing that a little bit, and do what I said about the terminal. You know, applications in the terminal should control the terminal to a certain extent. And also start kind of designing a system for handing off work from the current machine that you're on to another machine on your network, because I wanted my operating system to be distributed. And also my compiler compiles to C code, which then needs to be compiled by GCC. So I was thinking, can I create some system where the compiler running on my operating system so the compiler running in here in this terminal can be like cred doesn't obviously exist, but we will have to port it. It does that, and then I have some way of, because I want my operating system to be distributed. Why is there a weird line? Oh, that's the chat. Because I want my operating system to somewhat work in a distributed way. After it is done and it generates C code to then communicate with another machine on its own network, distributed network, which could be like a Linux machine running a special server, communicate with it and tell it, hey, can you pick up this compilation for me? And it could compile the GCC and maybe even return an executable. It's quite a lot of work, but the overall infrastructure is what I'm mostly talking about. I can maybe start designing that on Monday if the compiler is doing well enough, which frankly, it's doing pretty good. We're at a point where we are able to generate C code, and with that, we're able to experiment with the language itself. Okay, so it's important to start compiling to the operating, to make it work on the operating system as well. Okay, but that's it for today. Thank you so much, and I will see you tomorrow.